Hello, John here. Welcome to episode 4 of my stream, where we're going to add graphic commands to BASIC. Right, it's been a while since I've done this because I was otherwise engaged last week. So I couldn't do any streams, but here I am. And so we're going to start where we left off. Now, if my memory serves me correct, we've done... Damn Xbox. If my memory serves me correct, we has done the graphic command and the screen command. So we've created two commands that set up the high resolution screen, and we've created a command that puts us back into text mode. Now, the next thing we need to do is we need to figure out how to put a dot on the high resolution screen. And now I'm not too sure if you guys know how to do that. So, as part of my video series that I was going to do on this, I've done a load of slides. So pay attention, kiddies. It's teaching time. So, you know that we are using the upper memory block of RAM. So we have got our high resolution space in the 8000 memory area to B, C. I think it's two of them. So it's 8000 to C1000, I think. So we're using the memory space directly under BASIC. So because the VIC chip doesn't see BASIC whatsoever, it only sees the RAM. So we can use that. But we need to be able to put a dot in that memory. So if we say put a dot at X point and Y point, we need to be able to do that. So that's what we need to do in this stream. We need to work out how we're going to put a dot on the screen in the right location. So if we say 10,20, it puts it at 10,20. So here comes the lesson. See, even look, part 4, even my video series was in line. Part 4. And you could tell it was done ages ago because my slides are different. Anyway, so what is memory? Well, memory is an area that can hold, it's either on or off, holds a 0 or 1. So that's called a bit. Now byte is 8 of those bits. So if you imagine that it would be in sequence 8 of the bits in a line, but we always look at it in a horizontal space. But in reality, it's just any old how. Now memory has a list of bytes, and in the C64 arena, there's 65,535 of them, so 64K, all in a dirty great big long line, and that is represented by this bit at the bottom. So we are trying to represent memory as a sequential set of bytes. So when you look at it from the bigger picture, you can see that 8 bytes makes character, 16 bytes makes 2 characters, but they're all in a line vertically going down. But the VIC doesn't, I mean, it sees it like that, but it doesn't represent it on the screen like that, which is rather annoying because it would have been a lot easier to do that. But what it doesn't do the ZX Spectrum way either, because that's even more annoying. And what the VIC does, it looks at each character. So it takes this character, puts it on the screen, looks at the next character, puts it right next to it, looks at the next character, puts it next to it. So you end up with something like this. So the high resolution screen goes across the screen with its memory. So it does a byte at a time. So it does the byte, moves along, does the next byte, moves along, then does the next byte, moves along, does the next byte, and so on. And then when it's finished the row, it comes back to the beginning again and carries on. So the 64 has 40 characters. Now 40 characters can hold 8, but well, when we're talking going widthwards, it holds 8 bits, yeah, widthwards across the top. So therefore 40 times 8 means that the entire space going across the screen is 320 pixels. And also the C64 has 25 rows, 8 bits in each row. 25 times 8 means we've got 200 pixels down. So we have got a high resolution space. And what I mean by high resolution, it's either black or white. So remember that. A high resolution space of 320 across by 200 pixel down. And basically it is just 1,000 characters all laid out in rows and columns. That's what the high resolution mode is. It just plonks 1,000 characters on the screen, and then that's representing every byte of memory from the memory space that you've specified. And in this case, it's memory space 8,000 onwards. So how do we put a dot on the screen? So here we go. Here's our high resolution screen laid out in some sort of order, I think. Yeah. So row 0, row 1, 2, 3. And in this one, we've got 8 characters or 8 columns. So if we want to set that pixel right there, that one there, yeah, that one, then it's dead easy, yeah, because that's the first byte of the memory space that we are messing around with and the first bit of that byte. But we can't rely on that. You know, we can't rely on that. We can't rely and say, right, we know where that is, and then try and work everything out. So what we do, there is a formula for doing this. Now the formula is a good old-fashioned maths problem. So we have 2 variables. We have the x coordinate, which is running across the top of the screen. We have the y coordinate that runs down the side of the screen. So x can be between 0 and 320. Y can be between 0 and, well, 200, 199 to be precise, and 319 on the x-axis. So what you need to do is to work out, you've got to work out the column and the row. So to work out the column, you take the x value, divide it by 8, gives you the column. Row is exactly the same thing. You take the y value, divide it by 8. So then you've got 2 numbers. You've got your row number and your column number. Now, that only gives you the marker of 8 bits in either space. So we have to work out then, within that 8-bit space, both x and y, which bit is the one that we need to target. And the best way to do that is to multiply your row value by 8 and then minus it from the original x value. That gives you your remainder, and you do the same with the y. Now, people go blank when you start talking that, but it's not that hard. All you're doing is you're working out the major value of 8, which is your column or row, and then the minor value, which is the remainder. But instead of saying it's a half or quarter, we are saying that it's the 6th row across, 6th column across, with 2 left over. Right? And so when you come to working out where the value is, you first have to work out your base value. And the base value is the byte of 8 bits. So we need to find that byte on the screen first. So the way to do that is you times the rows that you times the row that you've worked out. What row is it? You times that by 320 because you've got 320 bytes in a row. And then you times the column by 8. Think. Yes, times it by 8. That then gives you your offset. And what I mean by offset is we start at 8,000, but it could be any number whatsoever. It could be 0. So when you times your row value by 320 and then times your column value by 8 and then add them together, that is what is classed as your offset. So that's the offset from the very first byte on the screen to wherever it is. Now in this example I've got at the moment, we've got an X of 0 and a Y of 0. So it's dead easy to work out because 0 divided by 8 is 0. So therefore, if you work out the remainder, that would be 0. But you've got to remember that if we say 0, then it's the wrong way round, yeah? Because the byte is always... Now, I'm doing it pointing to you, yeah? So this byte's 128, 64, 32, 16, blah, 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 blah. Now, if we do X divided by 8 and then do column times 8 and then X minus the result of that, you'll end up that way round. You'll end up there, right? So X is 0, divided by 8 is 0. 0 times 8 is 0. So 0 minus 0 is 0. It's there. Now that's the problem, because remember the screen starts here. So what you have to do is you have to do 7 minus your remainder. So 7 minus 0 is 7, so it moves it to across there. And this is why it gets a little bit... Are the slides of last time and is this time? Yeah, the slides will be available once I've sorted it out. And so 7 minus 0 is here, so the 7th bit, and that is the bit. So you've got to add a little bit of messing. But to get the base byte, which is that bit there, you times your row by 320, then add your column times by 8. That gives you your offset, and then you add your base value to it. Now the base value for us is 8,000. So we would add 8,000 to our offset. So if we work out our offset here, our offset is 0 because X is 0, Y is 0. So X divided by 8 is 0. Y divided by 8 is 0. 0 times 320 is 0. 0 times 8 is 0. Add the whole lot up, you get 0, right? So down here, so we have 0 and 0 for both our X and Y. Add our base value, which is 8,000. We end up with a proper offset of 8,000. And then we work out which bit inside that byte that we've just identified that we want. And that is where you are working out the remainder of X. And then you have to do 7 minus the remainder to give you the proper bit. And then once you've worked out the bit value, you have to do power of whatever 2. And that tells you what bit value is. Now that is nice and easy because X was 0, Y was 0. Okay, let's try another one. Here we go. So we want to do this dot here. This one here, right here. It's going to make it a bit more complicated. So here we go. We have a row value of 2. So we're on the 3rd row, because remember we start from 0. Alright, so 0, 1, 2. So we're on the 3rd row, and we're on the 5th column, because we start from 0, yeah? So we're on the 5th column. Now, to work that pixel, when we talk to the high resolution screen, we're always talking in pixels. We're not talking in bytes and things. So let's see if we can work this out. Right, so we are, let's see, so that's going to be 8, 16, 17, 18, 19, 20, 21, 8, 16, 24, 32, 3, 4, 5, 6. So they're the two numbers that I think that we need. So let's see if I'm right. Oh, look at that. Bang on. So X is 36, Y is 21. So here we go. So we've got the two variables. So we want to put a dot at location X36, Y21. So remember the maths. Remember the maths. First thing we do is we divide the X value by 8. Gives us 4. That's our column number, which matches what we've got here. Now forget the bits at the moment, forget the bit working out at the moment. So the row, do they exactly the same thing? Y divided by 8. So 21 divided by 8 is 2. If we go back, yes, it's the second, or row 2. Yeah. So to work out our base value, we times the row value, which was 4, by 320. Then we times, sorry, not the row 4, it's 2. Row is 2, column is 4. So we times 2 by 320. Yep. And I've put 644 for some reason. That's wrong. Right. So that is our row value, 640. Then we work out the column value. So our column value is 4 multiplied by 8, which is 32. So then we add our row location, row offset, and our column offset together. So in hex, that works out to 284 plus 20. Right? So that becomes 2A4. And then we add it to our base, which is 8,000 in this case, which gives us our byte location of A2, A4. So that is the byte we want to target. Now we have to work out what bit in that byte we need. So if we go back, we can try and figure it out. So I think our border's roughly there and there and there. So if I say it's there, then that's 0, 1, 2, 3. So I reckon it's the third bit that we need. So if we go back to here, then we can work out the bit location, which is dead easy. So it's X minus the column times 8. So 36 minus 4 times 8 is 32, which will give us 4. So there's our 4. But then you've got to remember, we've got to flip it, right? Got to flip it. So 7 minus 4 is equal to 3. So that's the third bit. And then what we do, when we to actually set it, it's 2 to the power, the number we've just worked out. And that's how you set that pixel on the screen. You first work out your byte location. Then you apply the bit location to that byte. Now we'll get to that in a bit. But that's how you work out where you need to be on the screen to turn on or turn off that pixel. That is the maths. Now, it's not rocket science, it's pretty easy when you break it down. If you break it down into steps, it's pretty easy. A lot of people try to do these complicated formulas and doing it all in one go and then get themselves all screwed up because they've put a bug in the formula. Break it down into steps. And the beauty of breaking it down into steps is then you can convert it to assembly code a lot easier because you're breaking it down into steps. Right. Let me see. Have I got anything else going on here? Yes. So, our screen is effectively this. So we start in the top left-hand corner. So for you, I think it's this corner. I think it's this corner, isn't it? Where's my screen? This corner? Yeah, that corner. That is 0, 0. And then you go 320 or 319 in that direction. And then 199 in that direction. So you've got a total of 320 across, 200 down. Remember, 0 to 199 is 200. 0 to 319. Now, we are not the BBC Micro. We don't have our axes inverted. So, what we're going to do is we're going to have a screen that's laid out like this. So we're going to have 0, 0 in the bottom left-hand corner. So it goes up by 200 and goes that way by 320. And the way we do that is we just, before we process the X and Y, is we do 200 minus Y. And that inverts it. Yeah? And that's all we need to do. That's all we need to do. Right. So let's concentrate on trying to work out the routines to mark a pixel on the screen, and then we will create the basic command to do that, which is plot. I think that's the command, plot. But the plot command is only the basic version of doing it, right? We need to work out the actual machine code to do it, all right? And so to break it down, what are the things that we need to work out? Well, there's effectively two. There's two routines we need to write. One is to work out our offset, our byte location. And then the other routine is to actually set the bit inside that byte. So we've got two routines to write. Do you agree? Is that what you was thinking? No? Yeah? No? Yeah? Does that help? Does that help? Because a lot of people can get really, really confused about how the high resolution system works. And they think it's really, really complicated to do it. And it's not. It's when you look at basic code, when people are doing basic code, you see this very long equation. And they're doing it, they're trying to be clever and they're trying to do it in one bit. But if you just split it up, it's not that hard. So what we're going to do, so here we are, we're back into our graphics extension. And we are not going to write a basic command. We are going to write the two routines that everything is going to use. Because you've got to remember, right? This plotting point, these two functions, the identifying the place and then setting the bit, are going to be used throughout the cartridge. It's going to be used in draw, it's going to be used in circle, it's going to be used in fill, it's going to be used in what else are we doing? Let's have a look. Box. What else? H-char reverse. Of course, yeah, reverse. I forgot about that one. And so these two functions are going to be the most used functions inside this system. So we've got to make sure these two functions are right. Now, once we've done those two functions, then we can write the plot command in the basic handler, yeah? So, first thing we need to do is we're going to have to create a new file. And because this is a library function, let's create a library file. So lib, now what did I call it when I was younger? Oh, right, graphics. Ooh, why am I doing capitals? Graphics routine. Is that what I called it? Graphic routines. There we go. Graphics routines. Okay. Right, let's grab this. Now we'll put that there. Right, we'll get rid of some of these files because we don't need them now. Screen, we don't need open anymore. Graphic command, we don't need open anymore. Chip locations, yeah, well that. CIA chip, no, we don't need that one. Cart initialization, yes, we'll need that because that's where we put our, yep, that's where we put our thingies. Tokenizer, Yes, we need that because that's where we're going to put our commands. Error handling. Are we doing an error in this one? No, we are not. We are using a basic error. Ooh, basic error. Here we go. Right, so let's put this in place. So this is the library of graphic functions that will be used throughout the code. So there's no inputs and outputs. So the first function that we're going to do is, right, so remember the two primary functions in the code. One was to identify the memory location that we're going to change. Now I called it place, so I'm going to call it the same again. So the place function. Now this function works out the byte location of the memory address to modify. Do you understand that? So we are working out the memory address location that we're going to modify by putting a dot in the pixel. Yeah. So what are, let's do this right. Let's do this right. Right. So inputs. So we've got two. X equals column location. Now, when I mean column location, I don't mean the character column location. I mean the pixel. In fact, I will put that in there. Pixel column location. And Y is equal to pixel row location. So they're the two we're going to use. Now, I am not sure. I'm not using the registers. No. I'm not using the registers, I'm using the memory locations. So the memory locations are here in the basic. So we're going to use COM-Y as the Y location and COM-X low and X high as the X location, because X319 is 2 bytes, not 1. So here we go. Place. There is our function. So we need to check that the numbers we're going to be passing, the numbers we're using, are within the range of our system, right? So clear carry. So we're going to load our Y value. So we're getting the Y pixel row location. Then we're going to compare it with 201.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, got a follow. Music Link. Thank you for following, Music Link. Welcome to the stream. Right, so we're going to compare it with 201. Remember, 0 to 199. So that really should be 200. Because we don't want 200, it's 0 to 200. So what we're going to say is anything bigger or equal to it, BCS. And we are going to go to place error. We'll call it place error. So we're going to, because if it's greater than that, we're going to say that's an error. All right. Now we don't need to check for the lower value because we start from 0, so we're fine. So let's do the x. So we're going to load com xi. I think that's it, yeah. Get x pixel column location pi byte. There we go. And now we are going to compare it with 1. Let me just check.
Hi, John here. Another subscriber. Stay a while. Stay forever.
A subscriber? Microman. 2 months. Hey! Welcome. Thank you for subscribing, mate. I've only got 3 subscribers. Doesn't matter. I love each and every one of you. Right. Now, x. 2 bytes. 0 to 319. Oh, you may have one soon, mate. You may have one soon. Right, so it's 2 bytes. So 319. So that means byte 1 has got to have 1 in it. So 1, that's 256. 256 to 300 is 44 plus 20, 64. Right. So therefore the high range is 0164. So we need to test that we're less than that. Yeah. So if we are, let's see. So we're comparing the high value. So if the high value is above 1, the high value is above 1. Let's just work this out. So BCS is 1 or is it? BCS is above or equal to. So if we say that's 2, then we can go BCS place error straight away because we know that that shouldn't be. Hey Warlock, how you doing? Morning, I should say. Morning, sir. Let's see, what time is it? Crikey, mate, you must be up early. Right, so we are saying 2 or above equals error. So therefore, if it carries on, then it must be either 0 or 1. All right. So if we compare with 1 now, and then do branch if not equal, 741. Yeah, it's still early, mate. It's still early. Right, so if we compare it with 1 and it's not equal to 1, that means it's 0. So we know that that's valid. So we can say go to workplace out. So we know that this is 0. So it doesn't matter what the value of the low is because it's legal. So it is legal. Now, the only other thing is that it's equal to 1. So therefore we need to then check X low. Because we need to then check for 64. 256. Oi! Pack it in! Shut up! Oi! It's alright, don't... It's alright. I bet someone's walked... Someone's walked in front of the door, I bet you. Right, so 256, so 320 to 256, so 256 to 300, it like to say 46 plus 20 is 64, yeah. No. 256, 44 plus 20, 64, that's right. So therefore, the only time we're going to be here is when the high byte is 1. So anything above 64, we're going to send to place error. Anything lower than that, in fact, no, I'm not going to make the same mistake as my younger self. Right, so BCC to work place out. So if it's less than that, so yeah, less than that, then we're going to go to work place out. If it's greater than that, then we are going to, so at place error, we are then going to jump to IQ error. Right, so if you don't know what IQ error is, let's have a look. ROM routines. Yeah, 63 or 64, but because we're testing with 64, if you do BCC, that's less than 64, so we should be all right with that. Right, so where is it? Here we go, IQ error. So if I load my infamous book in, where is it? Where is it? That one. Or is it that one? Where's the other one? Where's the other one? Anatomy. Here we go. Load up. Thank you. So, if we... have I loaded it more than once? No. So if we go back, so it's B248. So if we go to mapping and do find, there you go. This is the routine, right? It prints an illegal quantity error to whatever device is currently open. By default, it would be the screen, yeah? But if we go to the other one and do, see if I can do it here as well. No exact matches. What do you mean there's no exact matches? Oh, right, okay. Okay, okie dokie dokie dokie. Well, we need to go further than that next. Yeah, print output illegal quantity. Yeah, keep going, keep going. Keep going. Keep going. B248. Here we go. So this is the routine. So it's loading X value with OE, which is the error code for illegal quantity, and then it jumps to A437. Now, A437, where are we? Keep going, John. Keep going. There we go. Jumps to 0300, which we've hijacked. So it will go through our error routine. It will realise that it's an error less than 31, because it's OE, I think. And then pass it back to basic, which then comes to here and prints out the error. Right, I'll leave those books open. So that's what the illegal, this IQ error, it's to print out the illegal quantity error to the open device. Now the open device by default is the screen, but let's say if you've opened a printer channel up, it would print to the printer channel. But we're not going to be doing that. So now we've made sure that the numbers we're passing in are legal numbers, we can now go ahead and start working out all our bits. So work place out. Why did I call it workplace? Oh, work the place out. Huh, yeah, okay. My younger self called it place 2. Oh dear. Yeah, place 2, place 3, place 4, place 5. means absolutely nothing. Right. So the first thing we're going to do is we're going to work out the we're going to mess around with the y. Yeah. First thing we're going to do, mess around with the y. So the first thing to do is for the y, remember we've got to invert it. So we've got to do, so we're going to say row equals 200 minus y divided by 8. Right? Understood? Still with me? Do I have to go back to the slides to... Yeah, you're still with me? So what we're doing is we're inverting our y. So if we've said y is 0, we then say 200 minus 0 is 200, so it puts it at the bottom of the screen, and then divide it by 8. So the way to do that is load hash 200, set the carry, subtract com y, subtract com y. That will leave us with the remainder. Then we will clear the carry, and then we need to divide by 8. And to divide by 8 is 3 LSRs. So divide by 2. Divide by 2, which equals 4. Divide by 2, which equals 8. So that's our divide by 8. And then we're going to store the end result in com u. Don't ask me why. I can't remember why I called it that. My younger self must have had a reason. I think it was because... I think it's because... Oh, yeah. X, Y. I bet it... Because the other command is V. U, V, X, Y. Well, yeah. Whatever. So we store it in Y. So that's worked out our row. That has worked out our row value. Good question. Good question. Why am I using 200 if it's 0 to 199? Good question. There we go. Does that answer it? I'm just working, yeah. Yeah, my younger self did put 200 down. Yeah, it did put 200 down. Yeah, but you're right. So, now we've worked out our row, right? We now need to work out our column. So, our column is going to equal x divided by 8. We don't need them now. So, let's do this. So, I think we can do this a bit cleverer. Let me get the... where's my mouse gone? Let me get the instruction book up. Because my younger self did some rows, and I think we don't need to. Right, LDA. LDA. I just want to check something first. Where's LDA? There it is. Right, so if we load immediate, it doesn't affect the carry. Bring it on. Yes, we can do that. Right, so I'm slightly deviating away from my younger self. So what we're going to do is we need to divide, so it's logically shifting right. Now, so I'm going to, because I'm not going to do what he's doing. My younger self is logically shifting right the high value in memory, and that is not good. So what we're going to do is we're going to load the high value in, and then we're going to, it doesn't matter which way we do it, so it's going to be 1, right? So I need to get 1 into the carry, so let's logically shift right. Yeah, logically shift. So we're going to logically shift right. So this is either 1 or 0. And what we're going to do with this, we are going to populate the carry flag. So if the com x high is 1, we're going to logically shift it right, which will put that 1 onto the carry. Yeah. So what's the word I'm looking for? Initializes the carry. If it's 0, it'll logically shift 0 to the carry and sets the carry, so it keeps it clear. Then we can do load com x low. So this will be a number between 0 and 255. And now we can do the divide. So remember, we're going to be logically shifting right. So the first thing we need to do is right. So we're going to have a number that's potentially like this. So this is the carry, and then we've got 10, 10, 10, 10. So that is our byte, yeah? And so what we're going to do is we are going to put that, so we're going to shift that into here, yeah? And then that will shift over, so it becomes 1, 01, 01, 01, yeah? But to get the carry into the high byte, we have got to do a row. Yeah. Now that has put the 0 into the carry. Or if it was a 1, that means the carry now has a 1 in it. So to carry on the divide, so we've done here, so this is divide by 2. Divide 2. Now, we don't want to do another row because we don't want to roll whatever the carry's got back into the number. So we do an LSR, which is going to put a 0 in it. So divide by 4. And again, divide, oops. Which equals 8. Right, now like I say, my younger self, he did an LSR on the memory address. Now we don't want to do that because the memory address is where we're storing the actual thing. So we might need to use that. And I'm surprised it didn't have a bug, but I'll have a look in the plot. I bet I've taken a copy of that and stored it away. Now we don't need to, because we've pre-populated the carry, so the carry here will either be 0 or 1, no matter what. Then we load, and because I've gone and checked, on the load immediate, yeah, sorry, the load's absolute, whatever, yeah, it doesn't change the carry, doesn't change the carry flag. So we can then do, once we've loaded the X into there, we can do a first initial raw. So if the carry's set to 1, that'll be moved into the byte. If it's set to 0, it'll be moved into the byte as well. And then we'll do LSRs to complete the divide by 8. How clever am I? And then we'll store that into COM-V, which is the column number. Put their row number as well. Right, so do you want me to leave that in the comments? Shall I leave that in? Let's do this. Carry, space, byte, 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 byte. Right, so C means carry, the rest is bits of the byte. So I'll leave it in. I'll leave it in for you, Face. Why is this jumping over 8 characters? Is it set to 8? Screen editor. What is it, screen editor? Tabs. Where's tabs? Oh, I've forgotten where the tab is. No, 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 no. No, no. Oh, set to 4. Why is it jumping to 8 then? Right, so we've done the first two things. We've worked out our column, our character column, and we've worked out our character row. So we need to now work out the offset, right? So I just seeing what I do. Oh yeah, okay. So my younger self is just doing a simple multiply routine. So basically he's doing right, what have I called it? RW, yeah? So RW is row, so pixel row, we'll do that, is equal to row star 320. Now my younger self is just doing a simple simple multiplication. So LDY commu initializing the accumulator, storing it in com s low s high. Now the reason why I'm doing that, because right, my younger self has basically put this in here, so it's s equals u star 320. But because I'm trying to use more meaningful, even though I've created all these variables up already, I'm trying to give the comments a bit more meaning than the u's and the v's and the stuff like that, yeah? So initializing the start, we then oh, he's comparing it to start with. Really? Well, I know. Well, really? Okay. I'm sure I can make this better, but he's comparing Y with 0. So he's checking to see if we've already got 0 columns. Yeah. John Jr. Yeah. Sometimes I look at my code when that I wrote when I was a kid, and I go, oh my God, I was either brilliant or deranged, because sometimes I look at it and think, really, why am I doing that? Most of the time it's because I'm brilliant, but I just wondered why I was comparing it first, not last. Right, so if it's equal to 0, that means we don't need to do the multiplication, it's 0. So we will go to then work out. So this is row, so next one will be column. Right, so this is the row multiplier. It is, isn't it? You look at it. You look at you're absolutely right, FaZe. I mean, you look at your code that you did when you was a teenager. Now, for me, that was a long time ago, where dinosaurs were scattered all over the planet, and you think to yourself, "You what? Shut up! Play your Minecraft." No, there's no way, FaZe, you're older than me. No way on this planet you're older than me. You're not older than me, mate. You are a mere whippersnapper. I am older than you, mate. You're a mere teenager. I never watched Monty Python. My dad watched it. I didn't. Really, the hand needed a shave. I'm going to have to turn this HD camera off so you can't tell. Right, so we're now... Oh, the big 5-0 then, Warlock, eh? You're going to have a big party. Online stream party, mate. I'll be there. Right, so now we're in the multiplying. So we're going to be multiplying up. So we're going to load up com slow, and then we're going to add 64. Oh, we'll be done by then. Well, us Brits hopefully will be done by March. We should have the needle by then. Right, so we're adding 320 every time we are rotating round this routine. So we're doing a simple multiply. Right, then we do, so we decrease y, which is our looper, branch if not equal to 0, back to @row, come on auto tally sense, come on, you can do it, no. Yeah, the problem is, mate, with Australia, you guys shut everything. You've got armed police at the airports. Anybody that came in on a flight, you'd chuck back out again. We should have done that, really. We should have done that. Right, so it's going to be looping round here and adding 320 for every loop. So depending on how many pixel rows we've got, it will run through. So now we're going to be working out our column. So our column, and so this is the pixel column, is equal to What am I doing there? Oh, yeah, that's right. That's right. So pixel column is equal to 7 minus y. I'll do it here. Minus y star col cl star 8. But this is right. This is now a moment where I go, I was absolutely brilliant at what I do, because I've just looked at the thought, what am I doing? And it's just dawned on me, because what my younger self is doing is this. Pcol is equal to 7 minus y and 7, which gives you exactly the same result without doing the multiply by 8. I was just ahead of my time. Right, so we're going to do that. So we're going to load in com_y. We will AND it with #7. And then we'll store it in com_r. So my younger self has got this. So I'll do the same thing again. R equals 7 minus bracket y and 7. Yeah, so that's what he's got. So he stores it in R. Then we do the 7 minus. So set the carry, LDA 7, subtract com_r, store it in com_r. So that's now worked out our pixel column. Wow, I was seriously switched on. Right, the next thing we need to do is we need to work out our we need to work out our, so this is working out our, in fact this is not pixel row column, is it? It's pixel row. Yeah. It's better. I was going to say. So now we're working out our pixel column. So we're doing the same thing again. So pixel col is equal to x and 7. That's what I've written as my younger self. So we'll do the same thing. Now he's doing something. So he's loading. Now I'm going to work this out in my head while I'm typing it out. So he's loading in the x low. ANDs it with 7. And stores it back into com_c. So I'll do this. C equals x and 7. So that's what I've put in my note, in my comment, my one and only comment in these things. So he's working out the pixel column. Wow. So we don't even look at the high value. Oh, because he's right again. Because we shift out the 3 bits, don't we? We shift out the 3 bits. So the lower 3 bits is the remainder. Oh, I was just amazing. Right. Now we need to work out our base we know we need to work out our offset and add it to our base. So this part is now working out our memory location. Right? So our memory location is equal to the base plus, now S, he's put S. So that in our case, S is pixel row plus V star 8. V star 8. So V was the, what's V? Oh, there. That's the column, which we've already got here. No, we haven't. No, we haven't. So V star, so that's the col star 8. So we haven't actually worked out the pixel column, really. This is the pixel, not the pixel column. And then plus R. So R in our case is pixel row. So that's how we're going to work out our memory location. So he is right. So we're initializing the start. So have I got some memory locations that I can use? Right, where are we? Zero page locations. Have we got any 0 page locations set up? Doesn't look like it. Right, so let's set some 0 page oh yes, we have. Got one here. So I know F7. So if we go back to 0 page, I know on F7 we've got some more 0 page locations we can use without destroying basic. So F7 to F8 is RPOINT, and I think we can use this as well. This location points to the address of the 256 byte output buffer when using RS-232. Right, we can use that. We can definitely use that. Is there anything else we can use? Screen link table, no. Anything else? Pointer to the address of the current screen line, no. Can't use that one. Can't use that. Input output start address. Ooh, we could use that. Yeah, we'll use that. So style is C1, so we'll use that. Because that is only used when you're doing tape loads and saves. This location points to the beginning address of an area of RAM in which is currently being loaded or saved from the type IO. It will point to the cassette buffer, which is then used for the first block, blah, 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 boring, boring, blah. So this is not used in the running of BASIC. It's only used when we're using the tape. So that's what we're going to use. So we're going to use STAL. So save that. So we're going to store that in STAL, and then we're going to load our start base, which is A0, and and put it in style +1. So that's set up our 0 page for our base. Now we need to so we're going to add S. So the next thing is this here. So let me put my younger self's comment in. So it's basically $A1000 plus S plus V star 8 plus R. Right. So now we are going to add S. So let's clear the carry. Let's load style ADC com S low. Store it in style. And then we'll do load style +1. ADC com S high. Store it in yep. So we've added that. So now we're going to do the V star 8-bit and add that. So the way to do that is load 0. Oh, he's doing that. So he's logically shifting the actual value. Yep, we can do that because he's using it in the right way. So logically shift left com V. So that's 1, 2. So this one is multiply by 2. So now we've multiplied it up. Does a roll. 2, 4, 8. Yeah. CLC. Add it to stack +1, style +1, because this is the high byte. That's why he's rolled it. That's why he rolled the accumulator. Very clever. Very clever. It's just sad that I'm saying very clever to my younger self. And then we'll do the low value. So we'll load conv, which is what will be left over. Add it to style and then store it back in style. Now he's done a branch of carry clear bypass inc, where he's done inc style +1. So that's 2 bytes, that's 3 bytes, so that's 5 bytes. So yeah, I suppose it saves memory. So at bypass inc. Right. The last thing we need, so we've done this now, so we've done 800 plus S now, and we've just added V times 8. So now we need to add R. So clear the carry, load com R, add it to style, store it in there, branch equal. Ooh. That's why. But we're going to do this anyway. Branch of clear to bypass inc again. Inc that +1. bypass the ink again, and then that's it. So our end result, our memory location, is in 0 page stal, which is C1 and C2. So that is the function to work out our memory address. Yeah, that should do it. How can we test this out? How can we test this out? Should be able to test this out. Okay. Should be able to test this out, but I'm not going to test this out. Let's do the other bit first. Right, so let's do the other bit. Let's do the other function. So that's the first function where we are working out our memory address. The next function I called, where are you? Dot. This function sets or clears the pixel in the memory location set by place. Alright, so the inputs for this are 0 page C1 and C2 and com C. Right, so dot. So this is the function now where we are going to Why did I call it place and not location? Well, originally I called it place because you are placing a dot in that location. Could have called it location. Could have called it location, but either or. Personal preference, I think. Right, so this is dot. So this is basically where we're going to set or clear. No, it's setting. Yeah, this is setting. So he's setting. There's no clear on it. Just had a look. Right, so dot. This is setting the dot. Now this is where it gets a little bit. This is where it gets a little bit dicing because we have to do something. But let's do the thing first. So LDX comc LDY #0. So we're setting X and Y. So why is there a label there? Why is there a label there? Okay, we will put a label there as well. Set dot. So so here we are loading the byte mask, comma X. Now the byte mask is up here, I think. There we go. So this is our byte mask. So this is working out which of the bits we're going to set. So instead of trying to figure out what 2 to the power 3 is, we just load in the byte mask. And then, oh, why is it double hitting again? Then we OR it with stal, y, and store it in stal, y. RTS. There, done. Would you believe it? Now, we need another function. This is purely for the base. This is for the basic. And I'm not too sure. Have I got a basic ROMs function? Ah, yes, we have. Okay. So, am I doing that here already? That looks very familiar. Get number 2. This looks very familiar. But it's not the same as what we've got here. So, I am going to put that in here. And what this function is basically it's to get, I think this one is just a single. Get integer value from command line. Right, okay, it's from the command line, not from the basic program. So what we are going to do is we are going to create get number 2. This function gets a number from basic and returns the value in 2 bytes. Right, so the input is nothing because it's going to be basic. So the input is actually the basic program, and the output is going to be these two. So might as well use the same. So it's going to be that and that. So it's going to return a number in those 2 bytes. And we've called it get number 2. So get number 2. So we are JSRing a basic function, and it's called RFM_num. There it is. Now RFM_num, if my memory serves me, is, where are we? Basic ROM routines. RFM_num. Here we go. 8 AD 8A AD 8A. There is no match. You're joking. Oh, I bet this. Oh, it does. AD. Oh, it's here. There we go. So it evaluates a numeric expression and/or checks for data type mismatch. Right. So basically, this routine will look at the basic code, yeah, and if it's a mathematical expression or a function or something, it will evaluate that expression and then check to see if it's the right data type that we're going to be using. And in this case, it will be integer. So that's what that does. So that then gets, so if you put, say, plot A plus B times C, this function works that out and then returns back the number as a floating point. Then our next routine, so once we've evaluated the expression, we then do this, basic, and it's get ada. Now, get ada is get address, and that serves two purposes. So if I find where get address is, B7, F7, right, this converts. So when BASIC's evaluated the expression in the program, so it's worked out our mathematical equation or the number or whatever we've used, it stores it in the floating point accumulator. I think it's number 1. And then what happens? The get ada converts that floating point number into an unassigned 2-byte integer number. So it converts that number into a high and low byte, which is then stored in 14 and 15. So the end result of this is 14 and 15. So what we're going to do is we're going to output these two values. So A is going to be the low value and Y is going to be the high value. So equals accumulator equals yreg. So we've used two basic commands to get a 2-byte number out of BASIC, but it has to be an integer value. Right, that, and you'll see that we're going to use this a lot, an awful lot. Right, so we should then, oh, I can't even spell. I've just realised what I called it. Why didn't someone say anything? Round teens. Right, so we're going to include this in our project as a library. So we'll include it there. So we'll put it in there. Inc assem lib graphics routines.asm. So we load it in. Now it's not going to do much good for us because we're not calling it, but I'm just going to build it just to make sure it works. So build it to memory, see if we get any errors out of it. Looks like we're okay. Let's just see. So here's our functions. Look, there it is. So it's all assembled up okay. Right, let's write our next command. It's 9:30. Got time. So we are going to write our next command. So the next command we need to do is the plot. Now the plot command is to put a dot on the screen. So that command is going to use what we've just built in the routines. So let's find my plot command. Let's create a new file. So what have I called them? Inc plot command. There we go. So we don't need that. Let's shut that. We need the tokenizer because we need to put the command in there. Cart initialize. No, don't need that. Right, where's the screen? No. Let's use the much more nicer, this one. Let's use that. Right, let's plonk that there. So this is the plot command. Now, what else did I put on it? What else? Syntax, right. Okay, syntax. This function, this basic function, puts a dot in the high res screen. So that's what it does. Syntax. So the syntax will be plot. So it's either plot or, oh, is it rplot? No, it's plot. Now, P shift L. Yeah, P shift L. P shifted L. And then it takes inputs of X and Y. So let's put the ranges in. So X should be between 0 and 319. Y is a range between 0 and 2199. Right, no outputs. Right then, so let's see the syntax plot. So the actual syntax itself in full would be plot X comma Y, like that. So command. And I called it point. Oh dear. I must have changed it. Maybe point wasn't so obvious. Anyway, point. So that's the point. And I think the reason is because the other function, the other function, we'll get to that in a minute. I think so. We'll keep it the same, but it's going to be plot anyway. So what we're going to do is we are going to call that function that we've just written. Get number 2. So we are getting X coords, which equals 2 bytes, because X is between 0 and 319, which is 2 bytes, because the high byte will either be 1 or 0. So we'll store that in com X low, because the A value will be the low. Store Y in com X high. So that function has now just read. So we've evaluated this in the tokenizer. We have just read that expression there. That's what we've just done here. Now we need to check that there's a comma there. Now there's a specific basic function that does that, would you believe? Called check comma. Alright, so if we look for the ROM routine, check comma. So here we are. AEFD. So let's look in here. AEFD. Next. 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 There we go. So basically, this function here to AF11, no, it's there, AF43, no it ain't. That's the error message, syntax error. Yeah. So this checks to see if comma is next in the basic code. And if it's not, then it goes through here, which is then producing a syntax error on the screen. Right? So then we check for a comma, and then we need to then grab the Y value. Right? And that is a basic command routine already still. So bas underscore, and it's get byte C. There we go. Now that is just a basic routine. Get byte C, get byte C. Where is it? Where is it? Oh, there. B79E. B79E space. That should get it next. There we go. Oops, too far. So this is the routine that then gets just a single byte number from the program. So the Y could be a mathematical expression, and as long as it doesn't go above 255, it'll be fine. If it goes above 255, then you get an illegal quantity error, because that's the function that's what this function allows you to do, is to get a. So basically, it's the. Do you know when you in BASIC you do poke 1024, 26? It's that 26 bit that this routine's doing. Yeah. So that's doing the 26. So if you put poke 1024 by 300, you get an illegal quantity error. Well, we're doing the same thing here. So that's what that's doing. So we check for the comma, then we check to get a byte back, and if it's successful, the byte is in the X directory. So we're going to store X into com Y. And the reason I don't do the number check is because we're already doing the number check in the place routine. Then the next thing we do is JSR place, and then jump to dot. So this works out the memory location to change, and this sets the bit location of that memory location. And that's it. That is plot. Easy peasy, lemon squeezy. So right, we need to add it to our tokenizer. So plot is the next one there. So we will add it here. So word com point, I think I called it, -1, because we're doing a thingy, because we're doing a return subroutine. We need to add it to here. So we're going to add it to our commands. Inc asm inc plot command .asm. Right. Let's see if it works. Okay. Right, 64738. So we've enabled our basic. I'll make this bigger so you can see it. Hopefully you can see it now. It looks a funny shape. It's better. Right. So 10 graphic. Right, let's run it. Should put us in graphic mode. It does. Screen list. Whoops. So 20. Right, let's put a plot on it. Right, plot. What point should we activate? What point on the screen? Any takers? No? Let's make it easy. 10, 10. So we're going to put... Okay, mate, I'll do that as well. 101, 101. Right, so we're going to end up with 2 points. 10, 10, and 101, 101. Yeah, we'll do the four corners in a minute. So we should, when we run this, we should have 2 points on the screen set. Fingers crossed. There we go. Now, we've got a problem here. But 101, 101 is fine. So let's put screen back in. There we go. Right, so let's take 30 out. So we've just got the 10, 10. Let's run that. Right, we have got a problem here because it's set in more than 1 bit. So we are miscalculating somehow. So let's just see if that is... oh, I've just closed it and I didn't want to. Let's do that again. Oh, here we go. Didn't take them long to find out I was online. I can't administer while I'm doing, can I? No. Oh well, never mind. I can't administer my own stream, can I? No. No, I can't. That's a shame. Never mind. We'll let them have their fun, whatever. Right, so 10. $20. So we'll do the same thing again, plot 10, 10. But I'm going to do another one. So 30, plot 20, 20. 40, plot 30, 30. See if it does it all the time. There we go. Oh, hang on a second. All right. Let's that was interesting because we're getting different numbers. Right, so 24 I equals, oh, where's the equals key? Oh, come on. Where's the equals key? Ah, there it is. Equals 10 to 180, 30, plot I, 40, next I. Right, so that's going should give us a line going up the screen. So here we go. Ooh. Any takers? Can anyone tell me what I've done wrong? Anybody? You're close, mate. Where is this graphics? Where is this graphics RAM? What's my base address? Yeah. Remember what I said at the start of the stream? The VIC doesn't see the ROMs. The only ROM it sees is a character generator ROM. Yeah? So that's why we're using the memory underneath BASIC. But the problem is the 6502, when it reads the memory, it sees the BASIC. So this is the basic code. So we're reading in the basic code and then putting the pixel dot that we want in it and then storing it back to the RAM, not to the ROM, because what happens is when you poke to the ROM, it doesn't do it, it puts into the RAM. So we have got to swap out BASIC when we're doing it. And that's what we forgot to do. So let's go into the graphics routine. So it's in this dot routine, and what we need to do here is we need to, and I wondered what that command was and I ignored it because I forgot what it was. What plank. Right, where are we? There we go. So this function, what it needs to do is it needs to page out BASIC, do the thing, and then page back in BASIC. Now, how do we page out BASIC? Let's see if this gives us any hints. Here we go. So to page out BASIC, it's bit 0. So 1 means BASIC's in there, 0 means it's RAM. So that's what we need to do. So we need to affect location 1. So let's do that. So load 1, and we need to get rid of bit 0. 1 2 3 4 1 2 3 4. So that means that then that's going to be 1 2 3 4 1 2 3. There we go. Store it back in 1. So that's paged out BASIC. And then here we need to put BASIC back in, or we're not going to have a lot of fun. So LDA1, or it with hash percent 1 2 3 4 5 6 7 1. Store it back into 1. So here we are paging out BASIC ROM, and here we are paging in BASIC ROM. So we page out BASIC ROM, so all we see now is the RAM. So we do the thing, store it, and then we page back in BASIC, or we'll find out we'll be crashing all over the shop because it won't know what it's doing. Right, let's try again. F5. Yes, address 1 phase, correct. So let's try this again. Let's make it big. Right, 10, graphic. 20. Oh, no. What have I forgot to do? And that's destroyed it. Thought it might have done. Forgot to start it, didn't I? and it would have destroyed it because we didn't protect it. I will be doing, mate. I will be doing it in the future, but at the moment we're just starting out, so we have to. When I've finished, when we really get into it, it'll be just a case of pressing reset, you know, where we just go reset, yeah. So we'll do an Alt-R. So if we do it, I should be able to do it now. Alt-R. Yeah, there we go. So 10 graphic. That's it. 20 for I equals 10 to 180. Plot I comma I 40 next I. So here we go. Fingers crossed, ladies and gents. There we go. One plot. How about that? So there we are. We have now created the plot routine. So, you know, we can do what we like now. I mean, we get there, and now, well, that's going to be the next stream, because if you look at my things, look, the next episode is command to draw. Now I was trying to figure out, was there another command on here? RPOINT. Right, I thought there was another one. So now we've done the plot. The logical other thing is to detect whether that point is set or not. Yeah. So RPOINT is a command to read a pixel on the screen. So we should be able to do that with some relative ease, because all we're doing is reading the location. Now, I could yeah, let's do it. We got plenty of time, I think. Yeah, it's 10 o'clock. Got plenty of time. Right, so we've done the plot. Let's do the RPOINT command. So let's create another file. Inc RPOINT. Command. Got to spell it right. RPOINT command. Let's grab the header from here because I like that one. I might change the other headers now I've done that one. I'll do that off stream. So this one is RPOINT. Basic function that reads a dot in the high res screen. So it's going to be RPOINT or R-Shift-P. The inputs are going to be the same, but now we're going to get an output. So let's get going, shall we? So the output is going to be either 1 equals pixel set, or 0, which equals pixel clear. Right, so our syntax for this is going to be, so RPOINT syntax So RPOINT open bracket x comma y. So it's going to be a variable equals. Ah! Cheers, mate. So the way we're going to use it is we're going to have a variable that equals RPOINT bracket x comma y. Cheers, mate. So let's get started. So command RPOINT. Whoa. So effectively we're doing the same as point. So we can nick the code here. So we can nick this. Yeah, so we can nick this. Because we're doing essentially the same thing. But we have to change it subtly. Yeah? Right. Because we have to check for this. We have to check for that end bracket. Because when we do this, what basic does, it ignores, so we've tokenized to this. So we're currently on this character in the basic language, yeah? But because we've told it we're looking for a number, it ignores the bracket, yeah? Because what it does, it tries to evaluate the expression that comes before the comma. And so it tends to look, it tends to advance one and then do the expression. It's weird how basic does that. But it's already read this character, yeah? So when we say get a number of 2 bytes, it then starts at the next character and works out what the expression is. But when it's done this, it's currently here. So what we need to do to make sure that the person coding is coding it syntactically correct. Wow, that's a big word for this time of night. We need to do another JSR, and there's another one called check bracket. Where is it? Check comma. Check close, that's it. There we go. And that checks, so if we look at the lib routine, check close, AEF7. So AEF7 space. Go. There you are. Check on parenthesis close. Wow, that's a... And there we go. Here's the code that does it. So this, if you run this, will check for the parenthesis closed. If you run AEFA, it checks for the parenthesis open. And so we just want to check that the person who's coded this has coded it correctly by putting a closed parenthesis in. And then we can then start running our commands. So the first things we do is JSR place. We need to identify the byte the location. Identify byte location of bit to be read. Yeah. So we do the same as the plot, but the difference is we're not going to do the dot. We are going to read that memory location and then return the value. So if I go to the graphics ROM routine, we need to nick this. Right, so we'll copy that and then we'll paste it there. The problem is I'm not happy with doing that. Not happy with doing that. But we'll leave it, because I think in the future we're going to have to change this. So we bank out basic, then we load this exactly the same. We load the byte mask, but this time instead of doing an OR, we AND it with the memory location. Yeah, we don't need that because I'm not storing anything back. So we need to store this away, so we'll push it to the stack for the moment, and then we need to immediately bank BASIC back in, because we've read it and we've got the result. So then we'll pull it back from the stack, and now we're going to check to find out if that bit is set. And what we do is we're going to compare the accumulator with our byte mask, X, and then we're going to do if it's not equal to, so hang on, so we've ANDed it with our byte mask. If it's set, it won't be 0, so we're going to say branch if not equal to RPOINT return 1. If it's equal, that means it's not set, so we're going to LDA #0. And LDY #0, jump to BAS give AY. There we go. So this is going to return 0 in the floating point accumulator. Right, so if we look for that, give AF B391 B391 space. Keep going. There it is. So this is basically, it's converting what we've put into A and Y, which is 0 and 0, into a floating point number that is stored into the basic accumulator 1. Alright? So we jump away. Now, if we have matched our mask with what's in memory, then we know it's set. So we need to return A1. So we load A with 0 because that's the high byte, and then we'll load Y with 1, and we'll do the same thing again. We'll just jump to that. So that should load, that should return a 1 or a 0 depending on our state in the memory. So let's add this to our commands. So inc asm inc RPOINT command.asm. So we load that in, get to the cruncher or the tokenizer. So RPOINT is the next one, so we're on a right track here. So word com RPOINT -1. That should do it. Save that. Need to add a line here, don't we? Let me just put that in place. So what's the date? It's the 7th. Added basic commands plot and RPOINT added graphics functions and basic commands. Oh, look at that, it's just a byte. There we go, that'll fit. There we go. Right, so I've done that. Right, let's run this. So here we go. So F5. Okay. Right, Alt R. There we go. Right, 10 graphic, 20. So we're going to plot 101, 101, just for phase. And then 30, we are going to say X equals RPOINT, open bracket, 100, 100. 40 print X. Now, because we've set 0.101, 0.101, when we do the R point of 100, 100, that's not set. So we should get a value of 0 back. So let's try it. Oh, and a syntax error in 30. Okay, what have I done wrong? Maybe, is it tokenized? Let's have a look. Oh, hang on. So that's 100, 100. No, it's not tokenized it. X equals R point. Right, it's not tokenized it. Why is it not tokenized it? Have I got it right in there? R point. Why is that? Yeah, it's tokenized that, hasn't it? Yeah, because it's done X equals RPO B5, that's int. So for some reason, it's not read our text here. It's not tokenized it on that. Why? Okay. X. Let's try this. Right, let's have a look at that, see if that's tokenized. I'm just wondering if it's getting confused. Oh, 800. No, it's not tokenized it. Why not? Yeah, but remember we've inserted our code in before basic, so we should be reading our commands up front. Well, let's do that. RPOINT, RPNT. I don't like that. Why? It should be doing it. Let's do my typical typo. There we go. RPOINT. Right, let's do that. Let's see if that gets tokenized. Reset. So I'm not going to run it. I'm just going to do the x equals RPIONT because I've spelt it wrong now. 100, 100. Right, let's see if that's tokenized it right. Oh, no. It's still not done it. What's it tokenized now? On. It's tokenized the on. Right. We've got to figure out why this is not tokenizing that command. We should be in the middle of it. Oh, that's probably why, because I did a small t, didn't I? Yeah. Right, let's try our plot. Right, so we can't have our plot after plot because plot will be taken first. So we need to swap them over. Like that, yeah? So we'll call it our plot and plot. Let's see what happens now. F5. Yeah, pi is a reverse work. But the thing is, it shouldn't be tokenizing because we are doing our tokenizing first. So we should have tokenized it and then the basic interpreter wouldn't have seen it. But for some reason, it's not tokenizing and I don't know why. So 10. So we've called it our point now. So our plot x equals our plot open bracket 100, 100. Right. Memory monitor. That's better. So x space equals space CE. So it's tokenized it now. Right. We're on a winner. We are on a winner. So 10 graphic. 20 plot. 101, 101. 30 x equals our plot open bracket 100, 100. 40 print x. Right, that type mismatch in 30. Okay. We're getting a different error now. Oh, I wonder. Let's not do that. Ugh. Let's do this instead. Print our plot 100, 100. Print is very forgiving. Right. Do we get a type mismatch? Yes, we do. So what are we type mismatching on? What would it be erroring on? I wonder if we've got to check for the open bracket. So that would be +3. Right, Alt R, 10 graphic, 20 plot, 101, 101, 30 print, R plot, 100, 100, run. No. Right, so we are getting a type mismatch error from somewhere, so we need to do a bit of debugging, find out what's going on. Now, what could it be? Could be this. Well, it could be this, that it's getting, but it shouldn't be. Checks for comma, gets the number. Right, let's debug this, see if we can debug it. Come on, debug, toggle point, F6. No, debug, F8. I went into, did you see that? Went into VS mode. Oh, yeah, it's different. It's different. Right, I need to find. Oh, have I left it open? No, I didn't, did I? Where is my open containing folder? Where is my dump? Here we go. Notepad, where are you? No? Okay, we'll use that instead. So I need to put a breakpoint. Where do I need to put this breakpoint? Keep going, keep going, keep going, keep going. Here we are, here's plot, RPOINT. So I need to put 83F4, 83F4. Here it is. That's where the breakpoint is. Okay. Let's get this going busy again. Right. 10. Graphic. 20. Plot. 101, 101. 30. Print. R plot. On bracket. 100, 100. Right, run. Here we go. This is where we should find out where we're going wrong. And it's... didn't even get there, did it? Did not get there at all. Didn't even get to my run command. There we go. Now it's got to it. Interesting. Right, let's see if it does it though. Yeah. So, so this is a basic command. Oh, they're all OARs or ones. Where's the rest of the code gone? Yeah. But there's a problem here. 8400, it's overwritten the code. 8400 here. All the code after 8400's gone. That shouldn't have happened. Let's load it back in. Right. That should have loaded it back in. Ah, there's all the code log. Right, so the code's still there. 10. Graphic. Yeah, it's still there. 20. Plot. 101, 101. Still there. 30. Our plot. We'll just do this at the moment. 100, 100. List. Run. Oh, look at that. It's just wiped a load of the code out. So basic still thinks it's got access to this code because it's just wiped this out. What's it put in there? What's that? Is that just 010101? Yeah, it's just filled it full of A's. Right, so we've got to set right, let's load that back in again. Right, so the code's okay. So if I do run, fine, okay. 10, graphic, run. Right, so it's our graphic program wiping out. Okay, so we need to check. And that's probably why we're getting the type mismatch. Graphic, let's find out what's going on in there. What is going on in there? There we go. That's why. That is why. Where did I put this then? So I'm just looking at my younger self's code, find out where he put it. Oh, very clever. You naughty boy. You didn't tell me about that, did you? You naughty boy. Right. Okay. Have I still got that text editor open? No. Okay. Little skank. Right. What he's done is he's put another assembly directive. So when we well, let me see if I can find. Have I still? Yeah, I've still got it open. What's happening is I've not seen this because I've not looked at his code. I should say I've not looked at my code. I keep saying his code, but it was me. I did it. Right. So what's happening is he's wiping. This is the screen memory location here. So what he's done to avoid the code being overwritten, he's put in this. So I'm going to do the same thing. So he's gone and done here. He's gone and gone this here. That. So that bypasses the screen. And I've had it here, but didn't even click. Right. Let's see if that now solves my clearing out coding issue. It may not solve the phone going. May not solve the actual problem that we've got, but at least it might solve me wiping out my own code. Right. So, Control R. 10 graphic 20 plot 101,101 30 R plot 100,100. Right, list run. Right. So it's run it. So let's see if we can get a value. So let's do a percentage sign equals R plot 100, comma 100 list. Right. So that's an integer. Still doesn't like it. Still doesn't like it. Oh, 800. Oops, no, I need monitor, don't I? Just make sure it's still, yeah, it's tokenized it. So somewhere along this line, it's not liking it. All right, I'll have to look at my old code and just make sure I'm doing it right. Hang on. Let me see if I've got it here. I've got it here. What am I saying? Right, here we go. RPOINT. Am I doing anything different? No. Let's load my original one in. Yeah, the percentage signifies an integer number because we're returning back 100. I thought it may have been just that. But, I mean, we'll debug it. Let's debug it. So we know it's going to be at 800 somewhere around there, yeah? So let's click on that, stop it. Let's go to 8800 and see where the code is. Here we go. So that's 800. Oh, it's not even there. Oh, is it? Oh, it's there. There we go. 8800. Right. So we'll put a breakpoint there. So control reset. Yeah, the percentage sign in BASIC means integer. So we'll just do the x equals. Oh, what? Where's the equal sign now? Equals. Where's equals? Ugh. Oh, I don't know where equals. Where's equals? It's not here. Oh, where is equals? Backslash. Are you sure? Oh my. Well. I'll have to remember that. Right, so this should break, and it doesn't. Now, I'm supposed to be... Is it because I am returning back? I am returning back a floating point integer, a floating point number. That's what this is. But for some reason, it's not liking it. Right, I'll have to have a look at this, and I'll have to check my original code. See, have I got it here? Graphics extension, here we go. My original code. Yeah. Right, this is my original code. Right, where's our point? Here we go, our point. B391. Yep, that's the place. Why? I wonder if it actually worked. Let's load it up. File, open disk image. Am I there? Yes, I am there. Right, where are we? Is it there? Graphics extension 19. Right, Alt-Art. Right, let's see if it worked when I was a kid. Now it's our point. Ooh. I bet I suffered from... I bet this is a bug that I never saw. Oh yeah, it's done the same thing. So even my old code had the same problem. Right, I'm going to have to figure this out, find out what's going on. Because it looks like it was a bug that was there to start with. Oh well. These things are set to testers. Right then guys, it is 11:15. I hope you liked. I hope you're liking what I'm doing here, because this is meant to be different. Yeah, it means I didn't actually use it back then. Yes, I agree. But I do use a function to check, because that's... Where's my fill function? Where's my fill function? What did I use there to check if the point was done? Oh, it's actually in the fill. It's actually in the fill. Ah. And what's the other one that would check for a point? I think that's reverse, isn't it? Yeah, that's in the function as well. So I've actually copied the function. Oh, got different parameters going into it, that's why. Yeah, so it looks like I never used RPOINT when I was a kid. Well, here's a bug for me to fix as an adult. Oh dear. I'll figure it out. I think it's something to do with the end result. Maybe I'm putting it in the wrong floating point accumulator, because there's two floating point accumulators. There's accumulator 1 and accumulator 2. Yeah. But I'm hoping that you guys are getting a lot at this, because everybody's writing games. Everybody, even me, you know. But you don't see anybody trying to write an extension to the language, which is what this is all about. So I hope that you're enjoying what you're seeing. I know I haven't seen, there's not been many views on this stream, but that's all right. To be honest, it's over my head. Well, it's not. It's all right once you get. It's all right once you get the cruncher, the lister, the executioner, and the evaluator. They're the complicated bits. Actually, writing the basic function. Once you understand these basic routines, which you get out of this book, and also you get out of mapping, because if you go to there you go. So it's telling you like this, allocating space in memory for a string, B4, F4. Garbage collector. That's the garbage collector. I've just got to figure out the way I'm going to do it is I'm going to find where the equals code is to find out which accumulator they're looking at, because I'm putting the value into accumulator 1. Now the C64 has 2 floating point accumulators. There's floating point, that's floating point accumulator 1, and I think the other one's not too far away. There it is, floating point accumulator 2. So it has 2 floating point accumulators. Now I don't know if the equal sign is looking at floating point accumulator 1 or 2, and what I'm going to do is I'm going to look in this anatomy of the C64 for the equal sign code, and seeing what floating point accumulator they're looking at. Because if I'm populating 1 and it sees that I'm not, maybe that's where the type mismatch is coming from. I don't know. I need to look at it. But what we will do, if I don't fix it by the next stream, we'll carry on anyway, because the RPOINT... Is there a PDF of all the first publishing? I've got most of them, if not all. Hang on. Let's see. I think I got them all. First, here we go. That's them all there. That's them all there. I think I've got some of the first publisher ones, but no, I haven't. I've just got the these versions. So I've got them all, you know. And there's the anatomy of the C64 there. That's that one. I must have the other ones. Hang on. It's not in there. So first. Say again. Is it? Hang on. There, right, it's turned off now. Hey? Yeah, interrupting the stream. I must have them somewhere. But I've got I'm not too sure if these are the American books, because the first publishing was the British ones, weren't they? But these are all the American ones. You've got them all? Lucky boy. I think I'm missing the ideas book. A9, A5 is the let. Oh. Yeah, I know. There's a set of them in there, but I think someone's put a very big. Someone's put a big bid on the set. There's someone selling the set. Thanks, Microman. I will look at this and check which accumulator it's using. Right. Okay, so is the 1541 missing? All right. Well, it's I think it's gone past the 20 quid mark for all of them, I think, when I looked at it. Anyway, so the next one is going to be the interesting one, because we are going to be talking about drawing a line. So here we go. So the next one is to draw a line. That's what we're going to do. Now, drawing a line, there's a lot of mathematics going on. Now, the way I've done it in the past is using a lot of basic functions. And one thing I want to do is convert it away from the basic functions, because that slows it down. It slows the whole process down. But we'll do it the way I did it in the past, and then we'll talk about how we can try and update it, that we're not reliant too much on the basic functions for the mathematics, because there's a lot of converting from integer to floating points in there. So that's what we'll do in the next video. So I hope that you've liked what I'm doing. I would say I could say my end statement at the end of the YouTube videos, you know. If you like what I do, hit that like button. If you don't, hit the dislike button. Always leave me a comment, because I try and answer them all. And if you fancy being a patron of mine, please do. All the money raised for the channel goes back into the channel. Right, with that, I will say thank you very much, guys, for joining me, and I will see you on Wednesday. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.